Hello. Hello, is my voice clear?
Yes, sir.
Okay. Okay. So we are into the third lecture on unit number 2, and we are into the revision part. So we have seen about the embedded systems and how the embedded systems are working for IoT, how they are important for IoT. So beyond this, now in the third lecture, we are going to see some IDE environments. So as we have seen that what the IoT means, we have also seen that how the embedded systems work for the IoT. We have also seen the characteristics of the embedded systems, then types of embedded systems, and we have also seen how the embedded systems and IoT are correlated with each other. So beyond this, now we are going to see some more concepts of embedded systems that are important and that will work for IoT. So let us start with the definitions of the title. So we have already seen this, just a revision of the same. So a system is nothing but the arrangement in which all the its units assemble, work together accordingly to a set of rules. So that is what called as system. Then what is embedded? It is something that is attached with the another thing, and when we combine these two, embedded and system, together, it will become as embedded system that can be thought of as computer hardware system having software embedded in it. So that is called as the embedded systems. And when we say that embedded systems for IoT, we should know what IoT means. It's an Internet of Things. It is a network of physical objects or person called as things that are embedded with software, electronics network, and sensors, and that allow these objects to collect and exchange the data. So the ultimate goal is to collect and exchange the data by means of physical objects. That is called as IoT. Then the importance of the core, I've already said that embedded systems is nothing but a cornerstone for deployment of many IoT solutions. Major players in the embedded are aiming to bring these transformations into their product to take advantages of growing IoT market. And the embedded system in IoT applications includes networking hardware to home automation. So this is what the importance of the title is, of the course is. In this, we are going to see what is IDE environment. It's clear cut what we can say about IDE is that you need some kind of platform or the environment to write the program. When you write a program in that environment and in that platform, and uh, this can be flashed into the microcontroller or the processor that you have been working on. So by executing the program, you can execute the program through the IDE environment, and then you can put that program into the microcontroller or the Cortex M processor. So whatever you're going to do, that can be checked on the IDE environment. That is what which is very important. So we must know different IDE environments for different uh, uh, kits like Arduino, that may be Raspberry Pi. You may be having different kinds of controllers or the options, and through which you can write down the program and then you can execute it. So actually what IDE means, it is an integrated development environment that enables the programmers to consolidate the different aspects of writing a complete program. So I said that like it provides an environment for the programmers so that they can write the complete program, simulate it, execute it, so that so that the program is ready to be flashed into the memory, flashed into the processor. IDE increase programmers productivity by combining the common activities of writing software into single applications, that is editing source code, building executables, and debugging. So all these things you can do in IDE. That is, you can edit the source code. Once it is written, you can execute it. Even if there is an error, you can find it out, you can edit the source code, you can build the executables, and then you can also debug the program. So that is possible only on the IDE environment. The IDE also is called as an integrated development environment, and the IDE present on a single program in which all the development is done. So the single program is written as a project file, and then it is been development is done. This program typically provides many features for anchoring, authoring, modifying, compiling, deploying, and debugging software. So you can see that there are many features for authoring. You can author it, you can modify it, compile it, you can deploy it, and you can also debug it. Most modern IDEs have complete code completion. It provides a facility to the computer programmers for software development. Some IDEs also contains the compiler, interpreter, or both together. So you might be knowing what compiler and interpreter are. There are various IDEs available in the market today. Some of these are Eclipse, Kale, Arduino, NetBeans, Komodo, MPLab, Code Composer. This Code Composer is for the MATLAB. Then you LabVIEW and MicroC for PIC. So these are some of the various IDs that are used for the embedded development. Understanding the Eclipse. So let us see some of the examples of the IDE, how they work out to be. That will be easy to understand how this IDE works out. The open source Eclipse movement has become major factor in the software industry because it offers developers a free comprehensive IDE. It offers the embedded system developers for a very specific development tool to be easily developed, integrated, and deployed within an embedded system. The structure of Eclipse is analogous to Earth. So if you want to understand this Eclipse, how Eclipse works out, or how the environment is for writing the program, you can take an example of car. Now, how the Eclipse is equivalent to a car working, we see it. The Eclipse platform can be seen as a framework of a car. So the platform is nothing but the whole framework of a car, and everything else in is plugged into that framework. So the framework of the car is nothing but the Eclipse platform. So जो प्लेटफॉर्म है वो बिल्कुल अर्थ के कार के फ्रेमवर्क के जैसा है, और उसको जो प्लग किया गया है वो फ्रेमवर्क में, with resulting product being a complete running development environment. So likewise the framework के ऊपर प्लग इन किया गया है, उसी तरह से कार के फ्रेमवर्क के ऊपर प्लग इन किया गया है. Same exactly the Eclipse platforms has plug in, and that is to the framework, with resulting product being a complete running development environment. This plugging can be essential also. Example like engine of the car is important. So rest of the things are important or not, that's different thing. But this plugging is very important as far as essential to the environment engine of the car. So you can see from this diagram how the framework is there. So you can see that an Eclipse project is there. So there is a framework and these are all plugins. So the framework contains the Eclipse platform. This Eclipse platform is nothing but the platform, runtime, workspace, debug, then it may be a workbench, help, team. And when it is been plugged in with two things, the Java development tool or plugin development environment, that is PD, with another tool, with your tool and their tool. So you can have a lot of plugin tools to your main framework of the Eclipse. Then second one is understanding the Arduino. It is an open source electronic platform based on easy to use hardware and software. So where there is an Arduino code, there you require this Arduino ID. It is an open source electronic platform based on easy to use hardware and software. This ID runs on Windows, Macintosh, and Linux operating system. It is available for extension and experience. It is available for extension by experienced programmer. It is a single board microcontroller. It can sense the environment by receiving input from varieties of sensors and affects its surrounding by controlling light, motors, and other actuators. So this is a very simple. It can run on Windows, Linux, Macintosh operating systems. It is inexpensive, and the Arduino software can be expanded through C++ libraries. So you can easily work with C++ libraries. That is what the Arduino is. Now, this is the example of microcontroller based embedded systems. Now, you can design different microcontroller based embedded systems. This is just an example, like you have a number of sensors. These sensors will be given to the signal conditioning circuit. So it will be conditioned, it will be brought to a level where they can be processed by microcontroller. These sensors input outputs are all analogous, so they are converted into the digital, analog to digital, and then it is given to microcontroller where they can be analyzed, and then the output interfaces is given to the actuators where the comparison will be done and the output will be given. So accordingly you can design different microcontroller based embedded system. This is just an example. Now there are two types of things that has to be there. That is an Linux embedded systems. One, we have to understand this Linux based embedded systems. So today Linux can be found in embedded systems in many sizes, from mobile phones, home appliances, or vehicles. Many factors contribute to the Linux popularity, such as it is an open source, a very strong and committed community maintain and improves Linux regularly, because Linux is such an operating system where every day the changes are happening accordingly. So you can see that it is a very strong and committed community who are working on it. There is an always improvement in Linux. Henceforth, the Linux based embedded systems become very important factor. It is very flexible and support any hardware architecture you can imagine. So it is very flexible and support any hardware architecture you can imagine. Because it is deployed in millions of devices, its code is constantly tested in many different scenarios. Hence, it is robust. It is supported by the huge ecosystems of a software that consist of both runtime software and the development of tools. Now, these are the examples of Linux-based embedded systems. One is in-flight entertainment system. Linux is particularly suited for in-flight entertainment because it's simple, not weighed down by accompanying programs, and easily adaptable to many environments. That is why they are used in the flight entertainment systems. Second is a Tim Hortons Cafe and Bake Shop, where first time the Linux-based embedded system was used in order to display the messages about the menus of the cafes and shops. Then the gas station pump, the server displays the messages of a Linux bootloader. Just a moment. Hello, madam. So this is the Linux-based embedded systems in flight, in cafes and bake shops, a gas station pump. So the server actually displays the message of the Linux bootloader, and this gas station is actually powered by the Linux Ubuntu distribution with kernel 2.6.35. These are some of the examples of the Linux-based embedded systems. Now these are the components. You have a root file system where there is an application and system program, then a Linux kernel where there is a bootloader and device tree and hardware. So these are some of the components. Then examples of the Linux-based embedded systems. The first one is a bootloader where software executed to power up to set up the hardware to run the operating system. Then you have device tree. So you have a bootloader. This is the bootloader, just exactly about the hardware. Bootloader software that is executed to power up to set up the hardware to run the operating system. Then you have a device tree. Where is the device tree? Just besides the bootloader. A device tree is a tree data structure with nodes that describes the physical devices in the hardware needed by the Linux kernel to initialize properly the device drivers. And then you have a Linux kernel. You can see just above the bootloader and device tree. That is the operating system code providing all the services. हो एक 10 मिनिटं थांबता का? 10 मिनिटात लेक्चर मी फिनिश करतो. 10 मिनिटं. Device tree is nothing but a tree data structure with nodes that describes the physical devices in the hardware needed by the Linux kernel to initialize properly the device drivers. The Linux kernel, the operating system code providing all the services to manage the hardware resources. Then you have a system program. The system program is the user-friendly utilities to access operating system services. Then there is an application software implementation, the functionalities to be delivered to the embedded system user. A root file system container of the Linux kernel configuration file, the system programs and the applications. So these are the points. It was very short and all these points have been covered. Okay. Can you give me the attendance? Roll number 1, roll number 2, roll number 3, roll number 4, roll number 5. Hello, are you there?